In this section, we'll learn about different V-Ray geometries like V-Ray proxy, V-Ray fur, section clipper, and stuff like that. And we start this section with taking a look at V-Ray proxy. V-Ray proxy allows us to render extremely heavy scenes with hundreds of millions of polygons, which is not possible without V-Ray proxy. The way V-Ray proxy works, it imports geometry from an external mesh on your disk at render time only. The geometry is not present in 3ds Max scene and does not take up any RAM. The dragon model we have here in the scene is a fairly heavy model. It has almost 400,000 polygons. Rendering a few of this model maybe isn't such a problematic issue, but if I want to have 200 of these dragon models in my scene, that would be about 80 million polygons. Now, handling such a heavy scene is going to be problematic, and as it's going to need tons of resources and memory on your machine. Let me just quickly open up Frame Buffer so we can see what we currently have in the scene. And also there is some color correction going on applied to this render. To import the mesh file that we want to use through the V-Ray proxy object, that you can find it here in the V-Ray toolbar, first we need to export our object to a .vrmesh or V-Ray mesh file. Simply right click on the object and choose V-Ray mesh export. And after we exported the file, we can bring it back using V-Ray proxy object and distribute as many of it as we want in the scene. Up here in the folder section, you can specify where you want your V-Ray mesh file to be exported. So let's click on the browse button and go to the proxies folder of the project files folder for this lesson, or it can be export folder, it really doesn't matter, and press OK. Down here you can specify the name of the .vrmesh file that will be exported. Dragon.vrmesh is going to be okay. We have two options to export our object or objects. The first one is export all selected objects in a single file, which takes all selected objects and merge them into one mesh file, and then all of those objects that will be stored in one .vrmesh file can be brought back into the scene using one V-Ray proxy object. And we have export each selected object in a separate file, which exports one .V-Ray mesh file for each selected object. The name of each file is derived from the name of the corresponding 3ds Max node. In this case, we only need to export one object, and you can use both of these options, but in this case, let's use export all objects in a single file. The next important option is automatically create proxy. This option is not enabled by default, which I think it should be. When enabled, immediately after you click on this OK button and export your mesh, V-Ray automatically creates proxy object or objects for the exported meshes. The proxies will have the correct transformation and materials derived from the original object, and the original objects will be deleted. Let's make sure this option is enabled. The next important option is down here, which is create multi-sub-object material. This option is available when multiple objects with different materials are exported. So if I enable export all selected objects in a single file, now you can see create multi-sub-object material becomes available. When enabled, V-Ray will assign a multi-sub-object material to the created proxy, and the sub-materials will be assigned to the appropriate objects or faces automatically. But if the mode is set to export each selected object in a separate file, and like here you are only trying to export one object or even multiple objects, and you have multi-sub-object material applied to it, it will be saved in the V-Ray mesh file and will be rendered just fine when you bring it back using V-Ray proxy. Obviously, if you are trying to export an animated mesh, you need to enable export animation and define the frame range. Using export point cloud, here when enabled adds a point cloud representation of the mesh separated into different levels of detail. And down here, mean preview faces sets the minimum amount of faces that will be used as a preview on importing using ViewRay And max preview faces sets the maximum amount of faces that will be used as a preview on importing the mesh using ViewRay. Now we can go ahead and press OK. After a few seconds, you can see the original dragon object has been deleted and replaced by a ViewRay proxy object in the scene. And if I select the proxy object and go to its modify panel, you can see it is referencing the ViewRay mesh file that we just exported. You can see it says dragon.vr mesh, and if I click on this browse button, here is the dragon.vr mesh file that we just exported, and also a bunch of other ViewRay mesh files that we use in the sun and sky lesson in our lighting section. We can do the same process manually. So if I just hide this ViewRay_dragon object in the Explorer, first we need to create a ViewRay proxy object from the create panel or from the ViewRay toolbar. So in the toolbar, select ViewRay proxy and click anywhere in the viewport. And it immediately prompts you to define the .vr mesh file that you want to be used. In this case, let's select the dragon.vr mesh and press OK. Now we just need to adjust its transformation and put it where we want it to be. In this case, let's delete this new ViewRay proxy and unhide the automatically created proxy. Now if I go ahead and render the scene without doing anything else, you can see we get the exact same results when compared to our previous render, which was done with the original mesh. But right now we can go ahead and create as many copies of this ViewRay proxy as we want without choking the resources of our machine. Imagine if you want to distribute 1,000 trees in a scene, it would be impossible without using ViewRay proxy. Now, before going ahead and creating tons of copies from this ViewRay proxy object, let's go ahead and quickly take a look at some of the ViewRay proxy options in the modify panel. In the display section, you can control the display of the proxy object in the viewport. You can preview the mesh as a bounding box. You can preview from the file in edges or faces. You can display the object as a single point, or you can show the whole mesh with all its details. For now, let's set it to preview from file faces. If we would have exported an animated sequence, this animation section would be available to offset the animation to a specific frame or control its speed and stuff like that. Using this import as mesh button, you can import the geometry from the .vr mesh as an editable mesh object. We can also import Alembic files using the ViewRay proxy object. So if I click on this browse button and in the proxies folder, load this particles.abc file, which is an Alembic file, you can see if I just go to my perspective view momentarily, you can see we have the particle data stored in the Alembic file. Okay, let's get back to the camera view. Click on this browse button and load the dragon.vr mesh file again. Now let's populate our scene with dragons. Whoa. Let's go to the top view, shift drag the dragon on the X to the left side and make sure it's set to instance, so the .vr mesh will be loaded only once, and set the number of copies to 4 maybe. Now select one of the proxies and change the display type to bounding box. It can help with the viewport, and especially if you are it really doesn't matter when you are having 100 200 copies, but if you are planning to have thousands and thousands of copies, it would be better to set the display to bounding box. Now select all the existing one and shift drag them on X to the right side. Select all of them and shift drag them on the Y as instance and set the number of instances to 10. Now we have 100 proxies in the scene and we'll be rendering about 14 million polys. Now if I go to my second physical camera and start rendering the scene, you can see the render starts immediately without any hassle, which is amazing. Let me just stop the render and show you the final result from the history list. Okay, there we have it. It's really amazing. Now, and this way we have rendered our complex heavy scene without having any problem. For the final render, let's go to the physical camera 003. It has depth of field on and its target is on this front dragon. Now let's render the scene and see what we get. So here is our final render. Let me go to the denoiser pass. All the dragons in the scene have a subsurface scattering material. We have almost 40 million polygons in the scene and we had absolutely no problem rendering such a heavy scene thanks to V-Ray proxy. Now let me quickly show you another example. In the 0801 V-Ray proxy scene 02, we have the same proxy file being distributed in different places of the scene. You just have a different material applied to it. By the way, you can apply different materials to your distributed V-Ray proxy objects. If I go to the perspective view, we have the main light on the left side and this fill light on the right side of the camera. Also, if I open up the environment and effects window, we have this very environment fog with fog distance set to 400 centimeter and height to 300 centimeter. Also, scatter GI is enabled. And that's it. If I go ahead and render the scene, here is our final render. Let's first turn off all the color corrections and go to the denoiser pass. We get this moody render with the help of V-Ray proxy and environment fog. Let's enable white balance and set the temperature to something like 10,000. Also enable color balance, make the shadows a bit bluer, maybe 0.3, and the highlights a bit yellower, maybe negative 0.5. So we get this beautiful moody render with V-Ray proxy. So that's about V-Ray proxy object, and I will see you in the next lesson. Okay guys, in this lesson we are going to be taking a look at another V-Ray geometry, which is V-Ray fur, and as the name suggests, it allows you to produce some simple hair and fur in your renders. To create V-Ray fur, simply select the object you want to add the fur to. In this case, let's select this pillow object. Then click on the V-Ray fur from the Create panel or from the V-Ray toolbar. And you have added V-Ray fur to your scene. You can see a representation of V-Ray fur in the viewport, and the fur object itself is under Pillow 01 object. Let's select V-Ray fur and let's take a look at its parameters. First, you can specify the source object to which the fur will be applied. You can simply click on the object picker and choose any object you want. To get something presentable, in this case, we need to adjust the gravity value. Right now it is set to -3, and this is the force that pulled these strands down along the Z-axis. If I decrease it to something like negative 0.3, now the gravity does not affect the strands as much as before. Before adjusting anything else, let's go to the material editor, create a new V-Ray hair material, choose any of the hair presets that you want. In this case, let's use red matte to make sure the colors work with the lighting. Now apply the material both to the pillow and to the fur. If I go ahead and render the scene right now, this is the result we are going to get in render 01. Let's close the material editor and get back to fur parameters. Length is obviously the length of the fur strands. In this case, let's leave it at 15 centimeters. Thickness is the thickness of the strands. 0.2 centimeter, as we saw in the render, is not working with the scene and gives very thick strands. So in this case, let's set it to something like 0.05 centimeters. We have bend, which is set to 1 by default. When set to 0, the strands are straight, and as we increase the bend value, the strands start to bend under the influence of gravity. Let's set it to something like 0.7 for now. We have taper. Increasing this value will make each strand thinner in its upper end and wider in its base, and the value goes from 0 to 1. In this case, let's use something like 0.5. Now if we render the scene with these settings, this is going to be our render, which is render 02. Okay, let me close the frame buffer for now. In the geometric detail section, we have this nuts parameter, and as these strands are formed by connecting smaller straight line segments, nuts is the number of those segments, and if I decrease it to something like 3, you can see the strands become jagged. Let's leave it at something like 8. We have this level of detail, which when enabled, V-Ray will generate less fur geometry for parts of the scene which are far away from the camera. And start distance specifies the distance from the camera at which V-Ray is going to start implementing the level of detail adjustment. Up to this distance, the fur will be generated as specified by the user. After that, V-Ray decreases the density and increases the thickness of these strands. Let me disable level of detail for now. In the variation section, we can add variation to direction, length, thickness, gravity, and curl. The value is from 0 to 1. By default, all of them are set to 0.2, so they are going to have a 20% variation by default. In this case, let's set the direction variation to 0.3, length variation to 0.6, gravity variation to 0.5, and curl variation to 0.6. Now if we, right now we don't have any curl in the scene, but we're going to add it in a moment. If we render the scene, the result would be render 03. And if I compare it to our previous renders, we get a huge difference. In the distribution section, we can control the density of the strands. By default, it's set to per area, which specifies the number of strands per square scene unit. For example, if the system units are in centimeter like here, this parameter specifies the desired number of strands per square meter or per square centimeter, or you can set it to per face, which specifies the number of fur strands per face of the source object. Every face will generate the specified number of fur strands. In this case, let's increase per area value to 1, and if we render the scene, the result would be render 04, which is going to give us a more dense distribution of the hair strands compared to our previous renders. Let's set the per area back to 0.2. In the placement section, you can decide on which polygons of the source object will be used to generate fur strands: the entire object, only selected faces, or polygons with certain material ID. And in the curl section, you can make the hairs curly. Let's set the curl radius to 10 and number of curls to 25. And in the, can actually render the scene, and the result would be render 05 with the curl options right now. And in the maps rollout, we can control different properties of the strands using textures. For example, let's try controlling density of the strands with a map. Let's use a checker map. And now drag the checker map to the material editor. Set the tiling to 10 and 10. Change color 1 to a dark gray like with a value like 8, and color 2 to a value like 51. Now if we render the scene, we're gonna get render 0.6, and you can clearly see the checker pattern controlling the density of the hair. And the colors set in the checker pattern are a multiplier to the actual density value set in the distribution rollout. For the final render, let me clear this map for now. Enable curl and set it to 10 and 25. And if we render the scene, this is our first final render with a bit higher dimension and higher quality settings. And for the next render, let's turn off curl and just render it as simple as it is. And this is going to be our second final render. Okay, so in this lesson we learned about V-Ray Fur. I will see you in the next lesson. In this lesson, we take a look at V-Ray Section Clipper, which allows to clip away geometries or part of the scene using a simple plane or a more complex object. And Section Clipper is a render time effect and does not modify the actual geometry in the scene. We have the same scene that we started our V-Ray proxy lesson with. In order to add a Section Clipper, in the Create panel, go to V-Ray and choose V-Ray Clipper and click once in the viewport. And now we have V-Ray Section Clipper in the scene. To make sure the render I have in the history list matches with current scene, let's change the wireframe color for the clipper to 28, 149, and 177. Now let's go to the perspective view. Try rotating the clipper so it sort of matches the direction of the dragon in the scene. Let's move it so it intersects with the dragon. Also, let's move the clipper up a bit so we can see its arrow, which specifies the direction of the clipper. The size of this plane does not matter, and everything behind it will stay visible in the render, and everything in front of it will be removed. And if I render the scene right now, the result would be render 0.1, and you can see everything behind the plane is still there and the rest of the scene is gone. In this case, we want to use the section clipper to clip away only the dragon object. So using the exclude button down here, we can change the mode to include and only include the dragon geometry. If I press OK and render again, you can see in render 0.2 the ground plane is still there and section clipper geometry only affects the dragon model. Select the section clipper and go to its parameters. We have enabled, which turns the effect on and off. We have effect light. When enabled, section clipper will clip away area light sources as well. We have camera rays only. When enabled, the clipper will affect objects as they are directly seen by the camera, but they will appear unchanged to reflection, refraction, GI rays. I have this sphere with a reflective material applied to it in the scene. Let's make it visible. Now if I render the scene with camera rays only disabled, as you can see in the frame buffer, the effect of the clipper geometry is visible on the reflective surface. But if I enable camera rays only and render the scene again, the effect of the clipper is not visible in the reflection and dragon appears to be unchanged. Let's hide the sphere for now and disable camera rays only. Clip lights geometry enables or disables the clipping of light geometries like mesh light. So if you have a mesh light in the scene and you don't want it to be clipped away, you can disable this option. Even though right now, because we excluded all the other geometries from getting affected by the clipper, whether this option is on or off wouldn't matter for the mesh light and it would have been visible. We have use object material, and if enabled, the material from the clipped away geometries will be applied to the holes or new geometries resulting from the section clipper. And if disabled, we can apply a specific material to the clipper and that material will be used. Right now, because we haven't applied any material to the section clipper, as we saw in the previous renders, the wireframe color had been used in those specific areas. If I enable use object material and render the scene again, the same subsurface scattering applied to the dragon is used for the geometries resulting from the section clipper. We have set material ID and material ID. Set material ID, when enabled, the user can specify a face material ID for the clipper object. You can then use this ID inside a multi-sub object material to specify a different filler material for different objects. And material ID obviously specifies the face material ID for the clipped surfaces when set material ID is enabled. So if I enable set material ID and set it to 2, I can go to my material editor and select the dragon in the Explorer, create a new multi-sub object material, use the current subsurface scattering material as the material for the polys with the ID set to 1. Copy the material, change the overall color here to 67, 65, and 55, and press OK, and use this material as the second material. Now you can apply the multi-sub object material to the dragon, and if we render the scene, the result would be render 06. And as you can see, we have two different materials applied to the dragon geometry based on the section clipper. We have this icon text, which shows or hides the V-Ray clipper icon text from the viewport. We have this mesh mode, and if you enable it, it allows you to use another mesh in the scene instead of the infinite plane to perform the clipping. So let's enable it. I have this box in the scene and it has a simple noise modifier applied to. Let's hide it here. If I get back to the clipper again, I can click on this pick mesh button and pick the box as the clipping geometry. Now if I render the scene, as you can see in render 07, we are using our box geometry to clip away part of the dragon object. And if I compare it to our previous renders, we get a lot more detail on those edges. Next we have operation, which determines how the mesh will be used. Subtraction clips away anything inside the specified mesh, only render objects and parts of objects that are outside of the specified mesh. And intersection clips away anything that is outside the specified mesh and only renders objects and parts of objects that are inside the specified mesh. In the first render, operation mode was set to subtraction, and in the second one it was set to intersection. So in this one, only the parts of the geometry that are inside the box are rendered. Let's set the operation to subtraction here. Replace mesh with clipper specifies what to do with the mesh that is picked through the pick mesh button. When enabled, the mesh is moved as a sub-object under the V-Ray clipper object, and the clipper takes the place of the mesh. If disabled, the clipper just references the picked mesh. For the final render, let's quickly go to the material editor, choose the second subsurface scattering material, and increase its value to something like 180. 83, just a bit lighter color, and press OK. And here is our final render. Okay, in this lesson we learned about V-Ray section clipper, and I will see you in the next lesson. In this lesson, we'll be taking a very quick look at the remaining geometries that V-Ray offers. In the Create panel and Geometry tab, if you select V-Ray category, you can see we have a list of V-Ray geometries. We discussed V-Ray Proxy, V-Ray Fur, and V-Ray Clipper, and now we'll be discussing the rest of them. In the Render Setup window, let's turn off GI. Now the default lights will kick in when we start the render. First, we have this V-Ray plane or infinite plane. If I select it and click once in the viewport, now we have an infinite plane, and if I go ahead and render the scene, we get this infinite plane, and you can apply any material to it if you wanted to. And if I go to its modify panel, we don't have any specific parameters. Let me delete this plane. We have V-Ray sphere. If I select it and click and drag in the viewport, we can create a sphere. And if I render the scene, we get an absolutely perfect round sphere. Let's delete this sphere as well. Next, we have V-Ray instancer or particle instancer, and this allows you to instance any object on particles from a particle flow system. First, let's go to the particle systems category and create a particle flow system in the scene. Rotate it 180 degrees. Now if I go through the timeline, we have some particles from a particle flow system in the scene. And if I render the scene right now, we have cube defined as the particle shapes. Let's go to the particle view and make sure we don't get any geometries from the particle flow. Now let's create a sphere in the viewport, and say we want to have an instance of this sphere over every particle. Okay, so let's add a V-Ray instancer. In the modify panel, first define the source object, which is the sphere in this case, then add the particle system. Now if I render the scene, we get our spheres where the particles are. Let me delete the sphere and the instancer. Also, let's move through the timeline so we can see more particles in the scene. We have V-Ray metaball. V-Ray metaball is a geometric primitive that can be used to create a ray traced metaball out of an existing particle system. The metaball is created at render time and is not generated as actual geometry. So let's select V-Ray metaball and click once in the viewport. In the modify panel and particles section, add the particle flow system to the positive particles, and if we render the scene, we get a metaball geometry in the render. We have some important parameters to control the shape of the metaball. Particle radius controls the overall radius of each sphere around the particle. So if I go to something like 15 from 20, we get a more defined result. Threshold controls how close the metaball is to the particles. So lower values move the surface away from the particles, while higher values make the surface cling close to the particles. So let's try 0.1, 0.5, and 1. Let's set it to something like 0.8 here. We have step length, which is the main control for quality versus render time of the metaball's surface. Lower values produce a more precise surface but may take more render time. Higher values reduce render time but can produce artifacts. Let's try 0.1, 0.5, and 1. And finally, we have V-Ray volumetric, which is an important one, and we'll be talking about it in the next section, which will be about atmospheric and volumetric effects in V-Ray. So in this lesson, we talked about V-Ray geometries, and I will see you in the next lesson.